So I'm the one in between you and liquor, right? So I'll try to make it quick. But I have to say how grateful I am for all of you to have come here and express the love for Alooma and listen to what we have to say. I'm extremely excited. This is my first user conference ever. I mean, we didn't get to have one at my previous company. And you don't have user conferences in the military, where I spent 12 years. I also just landed this morning, so excuse me if I sound a little bit confused. Will do my best. But really, I'm really excited to see all of you here. And again, happy to speak with anyone afterwards over liquor as well, if you have any more specific questions. Also, if you want to come at me with pitchforks at the end of the talk, you're also welcome. I can take it. But the goal of this conversation is actually to talk about the future, or at least how we at Alooma view, in general, the future of data and what is next, and what have we done so far and what is coming up. So I think it was already mentioned a few times that I spent 12 years in the military. I actually, originally from Israel, lived here in the Bay Area until the beginning of this year, since the start of Alooma pretty much, and then moved back to Tel Aviv following my wife's job that was already mentioned. She got a position in Tel Aviv, so I followed her. And now working from the Tel Aviv office of Alooma or from the airplane seat, which I spend a lot of time on. And my goal is to speak a little bit about how the data usage have evolved and how, at least I believe, it's going to evolve, and I hope to convince you. And this is a recurring theme. I don't think I need to convince anyone in the room that data is the core asset of every business. Data is important. We can get competitive advantage using data. We can do good, cool stuff using data. And I also don't think I need to convince anyone following the conversation that have been going around today that data access is difficult and it's broken. And this is not a new problem. This problem exists for about 30 years, probably since companies have started to use data, getting access to data. But the world has changed. So again, in the past, we used to have everything on-prem. We had our NetApp storage and our on-prem Oracle or Teradata database. And we used our computers were in the server room where if we picked up the tiles, we could see the ugly cables running behind. And this was actually my life for a very long time. And today, we don't have that. I mean, some things have completely changed. So today, we move to containers and cloud compute on the compute side. And we move to cloud storage for the storage. And we have new generation cloud data warehouse and databases where we can pretty much get infinite scale in 1/10 or even less of the price. And that change have brought many changes also to data integration as well. And I think that, I've seen this image in one of the talks that I went to, and I really liked it. I think that if we start a new company today, it is extremely easy for us in theory. We just, start everything in a container, ship it to the cloud, and let it run. But whenever we look at a company that already has a footprint, that is a very difficult dragon to tame. Only the migration, the move to the cloud, and getting control of all of the legacy stuff that we already have on-prem becomes very difficult. And actually, what's funny is that last night, I've seen this on XKCD. Oh, and the resolution here sucks, but you should go. It's just your last one, which is amazing, where, so now, basically, whatever we had for on-prem is not working anymore. All of the data integration tools that used to work in the past no longer work. So what we do, we start building our own script. Too bad I didn't take care of the resolution before. But this is the alt text. And really, what we see is company after company after company building in-house those plethora of scripts and stuff that somehow stitch together and trying to be the new generation data pipeline. And of course, that's where Alooma came in, and that's where so we're still talking about where we are today. And Alooma came in, we've seen if we want to migrate or if we want to do that new move to the cloud, we have the servers, the application, the data. And of course, we focused on the database. So we said, OK, let's move our data to the cloud, keep data in sync between on-prem and the cloud, or between different cloud applications, or between our Salesforce and our Snowflake or Redshift. And that's where Alooma focused. And I think this is the Alooma that was built in the last 5 years and that you know today and people have been talking about, focused mostly on data migration. So take data from the mission of Alooma was and still is, take data from wherever it can be, do any transformation possible on that data and put it wherever it needs to be. So sort of a pipeline which is directional in a way. Taking data from someplace, transformation, put it wherever it needs to be for analytics. And that's also the architecture that you know, which is take everything from the different data sources, put it in the Kafka queue or in the incoming queue, run some code engine transformation, use the mapper as data catalog, and push it to the data warehouse. That's great. I think that have been very helpful for a lot of people, and I actually was really happy to hear new ways of people using it today as well. But I guess my next point is what's next, or how data is going to evolve, what we haven't figured out yet. So if I'm looking at the way we build applications, the first thing that I think people are starting to move into now, especially with Kafka and DataStream. So this is from 2005, the paper by Martin Fowler, and actually someone mentioned it today also, which is great. Let's go to event sourcing, which is not a new concept. Event sourcing and essentially what they're saying is, or what Martin Fowler was saying, and many people said it afterwards as well, let's not use state stores like transactional databases or like Redis or Elasticsearch or MySQL. Let's use an immutable event log and base everything off of that event log. And again, it's not new, but I think the tooling around it and the ability to actually implement it was very difficult in 2005. So I don't know, 13 years ago. And I think that today, with whatever we have in the market, like Kafka or other message queues, it is much easier at least to start building that event log and reading off of it. And essentially the claim was that everything that is essentially queryable should be a materialized view of that event log data. Should be something that we just is not the source of truth, is not that single source of truth. It's just a view of that event log. And again, if we look, we are done with server rooms. And Yoni also mentioned it earlier today. But we no longer care today about HVAC, about network, about power. We don't care about these things. And the abstraction layer of the compute is completely solved. So now, when we want to run our compute instances, we are using EC2, we're using GCP, we're using Azure. We don't care. We only care about RAM, about storage, about about the actual requirements that we have from the servers. We don't really care about where the server is running or how the network is configured, or essentially anything that's related to the cable behind the floor. And we're almost done with application servers. So I think that today also already a lot of our application workload is moving to Kubernetes, is moving to containerized. Some of it can run on Heroku. So the entire serverless, quote unquote, approach is also, it's still not fully there. Probably most of us still have applications running somewhere on an application server that they install Linux on, but it's going away. We are moving to Kubernetes. So, and definitely the technology is there, the tooling is there, everything around it is there. So we are almost done with application servers as well. But we're still building the applications the same way. So if we were talking about event sourcing, we are not really doing that. So we still have our application, we have our transactional database for the transaction, we have the key value store and the cache, time series DB, and we have log and batch ETL and streaming ETL. We have analytics. So if we look at the way we build applications, OK, this is now running on Kubernetes. Great job. What about all that? And that's still running on whatever you. So OK, now we don't have to run our MySQL. We use RDS. Yay. That's still not solving like 90% of our problem. And then if we are a big company and we have many applications, that's starting to look like this. And then those applications need to talk to each other. Because all of a sudden, that app cares about the state of a different application. So we start building all of those arrows between our applications. And essentially, even though we don't have servers anymore, even though we don't have even application server anymore, so everything is Kubernetes and containerized, it's still everything that we need to do with data, we still do like this, at least most of us. And that I can keep going and make it smaller and smaller and smaller. But I think you get the gist by now. So we've spoken about moving to event sourcing. The other thing, and that was actually mentioned as well, is that in order to be able to get a real and accurate result, and this was actually also brought in by Jay Krebs, somehow the credit disappeared here, in 2014, is let's merge the batch layer and the real-time layer. Because if you really, the reason is that our application requires real-time data. That's the entire reason we are building that complex structure that was in the previous slides with the state database, is because the application itself, it needs data in real time. It cannot build on the batch data. So the first step in order to be able to actually maintain that event sourcing architecture that we described is to be able to have one layer that merges them both and runs on top of the event log. So just have one layer, which is the real-time layer. And again, maybe 10 years ago, we didn't have the right tooling for this. We didn't have the ability to run stream processing at a speed and the reliability that was required for applications. But today we do. So we should do it. And there's the credit. Thank you. So if we look at how we want our new generation of applications to look, we want all of them to run on top of the event log. The event log is the single source of truth that's running all of those applications together. And then we want materialized views. Again, we still maybe want to use CRUD operation. I'm not saying we are not going to use CRUD operation anymore, like create, update, delete, which is what we usually do with transactional database. Just we're not going to care about the database. We don't want to care the same way we don't want to care about the HVAC system in the Amazon data center in Oregon. We don't want to care about the database that's powering our CRUD operation. We only care about its response time. We care about the velocity. We care about the volume it can hold. We don't care about how it's implemented. And we don't want to know how the sausage is made. So if we had an API that would give us the correct data access according to the data access pattern that we need, this is essentially the way for us to build application that way, or the way we want to build them, instead of that huge mess that we had before. So, and then how does the layers of abstraction look? So let's say we wanted to have that same EC2/Kubernetes experience for data application. In theory, if we could imagine how we would build those systems, we would have those event sources, and this is going to start sounding very familiar soon. We're going to have all of the places that generate events, which are applications, but also third-party vendors that we're using. Those generate events. All of those events will have connectors that will put them in an event log, or Kafka, probably. And then we will have different processing layers, which is essentially the logic of our application, everything that needs to use data. And we want to have common services. So for example, if we want cache, we just want a cache API. If we want search, we want search API. If we want CRUD operation, we want CRUD API. And we'll have connectors, again, that will generate those materialized views. And they might be still powered by MySQL. They might be still powered by Postgres. It's not like those technologies are dead. They still have merit. But we want abstraction for that layer. It's like the AWS data center in Oregon still have servers. Surprise, there are still physical pizzas in the rack. But we don't know about it. We don't know how they look. We don't care how they look. We just care about the API that we're getting to them. And we want to be the same with data. We want to only care about the API we get and to use the data access pattern that we need. So if I take this drawing and essentially what I'm trying to say, so this is, in my opinion, this is the future of data. This is how data application will be built in the future. And again, regardless of what Alooma will do or what any one of us will do, there will be some company in the world that will provide that interface to develop data application. Because that's probably the right way, and we do have enough compute power, enough tooling today to actually do this. And And if we look about layers, the layers of infrastructure again. So we said, OK, servers, check. We have EC2. We have all of those cloud providers. Applications, almost check, because Kubernetes and Heroku and Docker is almost there. Data is the missing layer, or the missing piece. And this is the layer that we are still waiting for to be abstracted. In my opinion, this is the long-term vision of Alooma. So if I take the same architecture diagram of Alooma that I think you've seen a million times, I'm trying to think, OK, how am I going to adapt that to create a runtime environment for data applications in general, and not only for the ETL part of the world? I actually see almost the same diagram. I see something that looks very, very similar to what I have today. So I still have everything that generates data. It's still going to the event log. That's part completely the same, no change. But now, instead of the code engine, which we use today to enrich events, we use for ETL application, quote unquote, I change it to processing layer. So I want it to be the runtime environment for any application, because the only thing missing is the common services. Because today, that code engine is a little bit limited. It doesn't have any APIs for interesting stuff, quote unquote. So it doesn't have API for crowd operation. It doesn't have API for key value store. It doesn't have API for search, because it was only focused on the ETL use cases. But let's say it did. And if it did, what would prevent me from running my entire data application on top of that layer? Again, it's not 6 months from now. It's not 12 months from now. And in the next 12 months, and maybe even 18 or 24 months, Alooma is 100% focused on being the best ETL product, on being the best product for data pipelines. But if I'm trying to look far ahead into the future, and I'm saying, OK, 5 years from now, what do I want to be? And this might sound a little bit too much, but I think it is possible, is to have the entire data application stack run on top of Alooma, and then provide the API layer to interact with any databases. And maybe in first step, not providing even the databases. You still use your own database, just get the API layer to connect them. And then, of course, the part, so currently Alooma has like one very common service, which is the mapper or the data catalog. But again, in theory, it can provide many common services. It could provide cache. It could provide key value store. It could provide even a transactional database with an API tooling. And again, that even might be a second phase after just giving an API to existing databases. But again, when I think, how would I build that application that would abstract the data layer, in my opinion, it would look very similar, just with an added tooling, added APIs, and added abstraction layer. Any question? I know it's a lot to take in. I hope I didn't kill you with PowerPoint. Yeah.
So since it sounds like to provide for that event log, you're talking about leveraging Kafka, and knowing that Kafka is just a finite store, like 7 days or whatever capacity it's hold there. Is the vision also to kind of fold that into like a data lake that you can go back as far back in history?
Yes, I'll repeat the question in case not everyone heard it. So the question was, if Kafka is the basis for that event log, but Kafka is finite, is there a plan to also put it into a data lake? So in my opinion, the real answer, and this is something that we are working on right now, is to make Kafka infinite store. And then, again, the sausage is made somehow. It will be put in some kind of an S3 bucket or some data lake. But for every perspective, and again, I think this solution also has to expose a Kafka API, that Kafka will be infinite. You should be able to go as far back in time as you want. And then if, for that, someone under the hood will need to read data from S3 and put it back into Kafka, that needs just to be part of the platform. Yeah? Yeah, all right. That is a good one. So how does an immutable event log work with a complex regulation like GDPR? So That is actually a great question, and actually a very difficult one, I think. Because again, we want immutable, but we want to be compliant with deletion of data. And here, so I think that there are several layers here. There is one layer, and this is an approach that some companies have taken that says if it is difficult to access the data, it's like it's not exist. And then I have to say this is, in my opinion, it's not the best answer. I'm just saying that I know some companies have taken that route. And then the answer is make sure that there are tooling inside the platform that will filter out data that have been marked to be deleted, and then you can the raw data still exists, but it's very difficult to access. I think the better answer, in my opinion, is automatic anonymization or encryption of that sensitive data, so that it doesn't exist once you revoke the encryption key. And that means it really doesn't exist because you cannot decrypt it, even if you really want it, even if you put all your processing power on it. And that's, in my opinion, the better answer. And it can, by the way, it can be done by just anonymizing with an irreversible function, which is, of course, easier. But then it means you can never get that PII information. And usually that's enough. But for stuff like fraud, that's not enough. And the other option is to encrypt it, and then encrypt it in a way that you can always revoke it. Revoke the key so that if someone really asks to be deleted, you can never decrypt their own data. And we can talk about the ways to do it as well. But definitely part of that infrastructure has to be you get GDPR compliance out of the box, because otherwise it will be very hard to use for any company that wants to be compliant. All right, thank you very much.